Hi again, Kayla. Here's the second question. Now, again, unfortunately, I'm not sure exactly where you are in the course. I'm looking at this and thinking, wow, this would be hard to do with the first principles kind of method that we used in the last question. Your formula here, the Q, which they're also labeling as dp, like which is d of p. We can simplify it a little bit by taking the 30 and multiplying it inside. And so we would get like two separate terms like this. Now, if we're trying to find the dp dq, or dq dp, I guess it is, we would just be working with the second term. We would just be working with this term here. And we would have to put the limit as h approaches 0 of the p plus h in there. And that's why I'm saying that it's going to become a little more difficult, because it's got a lot of algebra involved in it. I'm going to go ahead and do it like that. The other alternative is to use derivative rules, and I don't know if you've learned them yet. And this one would be the quotient rule. Because we would have one term which is the negative 30p, and the other term which is this bottom denominator function that we would put into the quotient rule and find the derivative. So I'm just wondering if I should wait and have you tell me which way you're expected to do this before I go ahead and make the video for this one for you. Or if you want me to do it both ways. I'll tell you what I'll do. Let's do the quotient rule, and then email me back if that's wrong, if you wanted it, using the first principles method with the p plus h, and then I'll just do a video for you like that, or I'll write it out for you anyways and send you a screenshot of it, okay? So if we do dq dp, which is the first derivative of this function, using the quotient rule, the derivative of 150 is 0. Every constant has a derivative of 0. And the quotient rule, it takes the top function, which I call u, and the bottom function, which I call v. And the quotient rule is that we take the derivative of u and we multiply that by v. Then we minus the derivative of the second one, the denominator function, and we multiply that by u, and then we divide the whole thing by v squared. So in this case, our derivative would be minus 30 times the square root of p squared plus 1, and then we would be minusing the square root, the derivative of the square root, so we would minus 1/2 times p squared plus 1 to the minus 1/2 times 2p for the chain rule from inside the bracket. And then we're going to have to multiply that by 30p because that's our u function. So let me take this out so it doesn't make it too confusing. Okay, so we're going to multiply that by, I guess we'll call it negative 30p because that negative sign is there, okay? And then that whole thing is going to be over the p squared plus 1, the square root, squared, which just gives us the p squared plus 1 if you square a square root. And so here we've got negative 30 root p squared plus 1. And then we've got 1/2 times 2, so they'll cancel each other out. And we've got a p here times another p, so we have negative 30p squared, and then that is times 1 over the square root of p squared plus 1, because that's what negative 1/2 means. I'm just going to write that right now as p squared plus 1 and show you what to do with it. Oops. Okay, p squared plus 1 to the negative 1/2. Okay. and that's still over p squared minus 1. So what we have to do is we are going to rewrite this function, the square root function, as an exponential with a fraction. So it's p squared plus 1 to the 1/2, which means the same as square root of. And so let me move this up, show you what that's going to look like. We have negative 30 times p squared plus 1 to the 1/2 minus 30p squared times p squared plus 1 to the negative 1/2 all over p squared minus 1. Is it minus 1 or plus 1? How did I get the minus? Okay, plus 1, sorry. Alright, so we're going to common factor the numerator now. We're going to take out a negative 30, for instance, because that's a common factor in both terms. And then we're going to take out the smallest exponent of the bracket, because the brackets match, so we can do a common factor there. And the smallest exponent is the negative exponent, the negative 1/2. So what we're left with is a p squared plus 1 here, so that we would bring that back to p squared plus 1 to the 1/2. And then over here we just have minus p squared because we factored everything else out. And then it's over p squared plus 1. P squared minus p squared is 0, so we just have 1 in that bracket. So we have now negative 30 times p squared plus 1 to the negative 1/2 over p squared plus 1. And the very last step for this function is going to be to simplify one more step, which is going to be negative 30 on top. And on the bottom, because this exponent here is negative, it really means that it goes on the bottom. And so we would have p squared plus 1 square rooted times p squared plus 1. That's really p squared plus 1 to the exponent 1/2. And this is p squared plus 1 to the 1. So I would have p squared plus 1 to the exponent 3 over 2. And that is dqdp, and that's the rate of change. Without any more information like a number to put in there, you can't actually get the rate of change as a number. This would just be a formula, and you could substitute any value of p to get dqdp. I hope that helps, and if that's not how you're supposed to do it, if you have not learned your derivative rules yet, can you email me back and I'll do it the other way for you.